Hey everybody, welcome back to Quesadilla Math. I'm your host, Mr. Padilla. Today we're going to be talking about adding and subtracting rational expressions. Let's get to it with starting out with some fractions. Alright, so here we go. So what you got to know, whether you're adding fractions or you're adding rational expressions, the key is going to be finding the least common denominator. Let's take a look at some examples here. So our first example has us adding 3/4 plus 9/4. So this is the simplest case when we have common denominators already. In this case, 4 is the same denominator for both fractions. So all we have to really do is just add the numerators together. So 3 plus 9 gives me 12, and you do not add denominators when you add fractions. So make sure you keep the same denominator. Of course, 12 over 4 can be simplified. 12 divided by 4 is 3. So in our second example, we have 5/2 plus 5/8. Now, even though we have common numerators, we still cannot add these fractions until we have created common denominators. In this case, I noticed that 2 and 8 actually have a factor in common already. In fact, 8 is just 4 times 2. So really what I need to do is multiply my first fraction by what I like to call an ugly 1. In this case, 4 over 4. So I'm going to go ahead and multiply the first fraction by 4/4, just an ugly 1, and I'm going to get 20/8. And I'm going to add that with 5/8. Now that we have common denominators, all we have to do is just simply add the numerators together. In this case, 20 plus 5 is 25. We keep the denominator 8. And for example 3 here, we're going to be looking at 2/7 minus 3/8. In this case, we don't have any common factors already built in. So we're going to have to pull my favorite trick, which is to create a least common denominator simply by multiplying by the other fraction's denominator. The first fraction I'm going to multiply by 8 over 8. The second fraction I'm going to multiply by 7 over 7. This is going to go ahead and give me 16 over 56 minus 21 over 56. Now that we have common denominators, we just have to subtract. So 16 minus 21 is going to be -5 over 56. The fraction itself can't be simplified, so that does it. So now let's move on to some more complex problems. Okay, for our first example, we have 4x minus 3y over 5x minus 8x minus 8y over 5x. So luckily for us, we already have common denominators. So this is just a simple subtraction problem. However, you do want to be careful in this situation because you are subtracting the entire numerator. So what you really want to think of this is going to be -8x and a plus 8y. That way we can go ahead and combine these this way. So we'll have 4x minus 3y minus 8x plus 8y all over 5x. Now, we can go ahead, now that we've combined both of these fractions into one, we can go ahead and subtract, combine like terms. So 4x minus 8x is going to be -4x. Negative 3y plus 8y is going to be positive 5y over 5x. Now, we could try to simplify our rational expression now that we've finished adding it, but in this case, that's as simple as it gets, so that's our solution. In our next problem, once again, we have to deal with common denominators, which is great for us because that means we don't really have to do too much. All we have to do is simply add the numerators. So I'm going to go ahead and add the numerators, 11c minus 7 plus 4c plus 1. Because we're adding this time, I don't have to worry about distributing anything. And of course, over 3c. One more time, do not forget that you don't add the denominators. All right, so let's combine like terms. So 11 plus 4 is going to be 15c, -7 plus 1 minus 6, all over 3c. Now, we might think we're done, but we can actually still continue this just a little bit further because I can actually factor out a common factor from my numerator of 3. If I factor out a 3, I'll be left with 5c minus 2 over 3c. Now I have a common factor in my numerator and denominator that can be canceled out, in this case 3. So I will go ahead and cancel out these 3's, and I'll be left with 5c minus 2 over c. Once again, that's as far as we can simplify, so there's our solution. Our third example is involving quadratic denominators, but luckily for us, they are the same denominator, c squared plus 7c plus 12. So in this case, we can go ahead and, like normal, go ahead and add the numerators. So in my numerators, I have c, and I'm going to be adding to that 3 over c squared plus 7c plus 12, our common denominator. Now, just to make sure we can simplify it, let's try to factor that denominator. In this case, we have a pretty easily factorable denominator. It's going to factor out to c plus 3 times c plus 4, which means that we can cancel out a c plus 3 from our numerator and denominator, leaving us with just 1 in the numerator and c plus 4 in the denominator, which is as simplified as we can get it. So that is our solution. For our next example, we finally come to a couple of fractions that do not have common denominators. So how do we deal with a situation? So in this case, what we need to do is create common denominators just like our fraction before. So we're going to have to consider what our least common denominator, or LCD, is. In this case, our least common denominator is going to be 15x. And this is because I can actually take the first fraction, multiply it by 5x over 5x, another ugly one. My second fraction can be multiplied by 3 over 3, a slightly less ugly one. So now let's go ahead and see what those fractions will look like once they're multiplied. So we get 40x over 15x plus 21 over 15x. Since we have a common denominator of 15x, we can go ahead and add the numerators. We end up with 40x plus 21 over 15x. Since there's no way to simplify this further, this is our solution. So in example number 5, again, we have to subtract a pair of fractions with unlike denominators. So we're going to have to find our LCD, which in this case is going to be 14c, because we can multiply our first fraction by 7 over 7 and our second fraction by 2 over 2. That way we get a common denominator of 14c. Now you have to be careful here because our numerators are binomials, so you're going to have to make sure and use the distributive property carefully when you're multiplying these. So let's go ahead and multiply it out. So now that we've multiplied out our numerators, let's go ahead and subtract these. Now, of course, you're going to have to be careful because 2c minus 10 is going to be subtracted, meaning that we're going to have a negative 2c and a positive 10. So our combined fraction is going to look like 5c plus 38 over 14c, which cannot be simplified, so this is where we finish. So in this next example, we're looking at a couple of fractions that already have some common factors in their denominators. So we'll think about our LCD in this case as being 18u cubed, because I can take my first fraction, multiply it by 3/3, and I can take my second fraction and multiply it times 2u over 2u. That way we get 18u cubed for our common denominator. So let's go ahead and multiply that through. So once we've multiplied, we can go ahead and combine our fractions together. In this case, we will end up getting 21 minus 4u over 18u cubed. And since, once again, we cannot simplify, this is our answer. So for example 7, we're looking at one fraction that has a monomial for a denominator, subtracting from another fraction that has a binomial in our denominator. So this shouldn't really make much of a difference. In this case, actually, our least common denominator is in some ways easier to find, because I can actually say that the LCD in this case would be x times x plus 1. Now, I actually like to leave it in this factored form here, so that way it just makes things a little bit simpler. But you can go ahead and multiply that out if you wanted to x squared plus x, but I wouldn't really recommend it. Leaving it in factored form might save some time later. So let's go ahead and multiply our two fractions. Our first fraction looks like can be multiplied by x plus 1 over x plus 1. Probably the ugliest one we've multiplied with today. And our second fraction can be multiplied with x over x. That way we get our least common denominator of x times x plus 1. So let's multiply through, and don't forget to distribute. So once you've multiplied through, we can go ahead and subtract. In this case, we really only need to subtract 6x minus 5x, which gives us 1x plus 6 over x times x plus 1, which again you can leave in factored form, or you could write it as x plus 6 over x squared plus x. And either way, here's our solution. Now in example number 8, we have both fractions with binomials for denominators. And if we look carefully, our first denominator can actually be factored to 6 times x plus 4, meaning that we actually have part of our common factor already done for us. In fact, to find our least common denominator, all we have to do is multiply the second fraction by 6 over 6. So let's go ahead and do that. So in this case, I didn't distribute the denominator, mostly because I like to keep it in factored form. So now that we've multiplied through, we can go ahead and add our fractions. In this case, we're going to get 5 over 6 times x plus 4, which again you can write as 5 over 6x plus 24. Either way will be acceptable. For our penultimate problem, now we're looking at a sum of fractions that have quadratic denominators. Now, in order to find the easiest path towards the least common denominator, my first suggestion is, of course, to factor. So let's go ahead and factor those denominators. So after having factored our denominators, you might notice that there's actually already a common factor between them. 3x plus 1 is present in both fractions. Now, in this case, we're going to have to think about what our least common denominator is going to look like. So remember that a least common denominator has all the same factors. So we already have one of those. That's 3x plus 1. Now, both of our fractions are going to also need to have x plus 3, since that factor is present in our first fraction. Now, our second fraction also has the factor x minus 1. So our least common denominator is going to look like this. So that means I'm going to need to multiply my first fraction by the missing factor, which is going to be x minus 1 over x minus 1. And our second fraction is going to be multiplied by x plus 3 over x plus 3, multiplying by the missing factor for both so we can get our LCD. So let's go ahead and multiplying out. So I went ahead and multiplied and added since we have common denominators. So all we have to do now is simplify our numerator. In this case, we'll get 6x plus 2 over our big denominator 3x plus 1 times x plus 3 times x minus 1. Now, we can actually still factor out a 2 common factor from our numerator, leaving us with, oh wow, look, 3x plus 1 over that same big denominator. So now we can cancel out our 3x plus 1 and be left with 2 over x plus 3 times x minus 1. And that is our simplified fraction. So for our last example, I decided to go ahead and surprise you guys with yet another complex fraction. So like in our previous video lesson about multiplying and dividing, here what you want to do is you want to attack it one piece at a time, in which case I mean start off with the numerator and then also the denominator. We should go ahead and subtract these, combine our two fractions in both. So I'll start with the numerator. In this case, in my numerator, I can multiply my first fraction by x over x, my second fraction by 5 over 5. That way I get the fraction that looks like 9x over 25x minus 45 over 25x. So now let's do the same with our denominator. In our denominator, it looks like I'm going to need for my first fraction a factor of x in the denominator, so I'm going to multiply by x over x. And in the second one, I just need to multiply by 25 over 25. So I'll go ahead and write this out as x squared over 25x minus 25 over 25x. And I'll go ahead and put that big fraction bar here. So at this point, we can go ahead and subtract our fractions in our numerator and our denominator to combine them. So going ahead and combining our two fractions in numerator and denominator, now what I'm really looking at is actually just a division problem. So I'm going to go ahead and rewrite this as a division problem with my numerator as 9x minus 45 over 25x divided by x squared minus 25 over 25x. It's really the same thing. So of course, to divide fractions, we need to keep, change, and flip. In other words, we can multiply 9x minus 45 over 25x by the reciprocal of the original, which is now 25x over x squared minus 25. So I'll go ahead and multiply these through. 25x's are going to obviously cancel. And I'm actually even going to factor out a 9 from my numerator. 9 times x minus 5. And my denominator is actually a difference of squares. So I'm going to have x plus 5 times x minus 5. So now we know that x minus 5 will be canceled out, leaving us with a simplified fraction of 9 over x plus 5. So our complex fraction, not so complex after all. All right, well, thank you guys for watching. I will see you all next time. Bye.